Okay, so let's look at this next section. This next section says that we are working with formulas and problem solving. Now look at the directions. It says solve for the indicated variable. Here's the deal. You know how to solve equations. This section is no big deal. But instead of dealing with pure numbers and one variable, now I've got an equation that's full of variables and I need to stay focused on which one I'm trying to get by itself. So look at number 1. Number 1 gives us the equation d equals rt, and it's asking us to isolate the t. So stay focused. I need to get this t by itself. So what do I need to get rid of? I need to get rid of the r. And what operation is keeping the r and the t attached? Good, multiplication, which means you're going to have to do what to both sides to get rid of that r? Good, you're going to have to divide, which means I'm going to get d divided by r equaling t. Now the question is t by itself? Yes, it is. So are we done? Yes, we are. Does that make sense? Stay focused. What variable are they wanting me to isolate? Look at number 2. They're asking me to isolate the y. So I need to stay focused. I need the y by itself. So everything that's not a y has got to go. Do you notice there's a 2x on the same side as this y? So does the 2x stay, or do we have to get rid of it? Yeah, we got to get rid of it because I need to get the variable y by itself. And how are you going to get rid of the 2x? Good, you're subtracting it from both sides, which means I'm left with 3y equaling 17 minus 2x. And then? Good, now the 3's got to go. And how are you going to get rid of the 3? Yes, you're going to divide both sides by that 3, which means we end up with y equaling 17 minus 2x, the whole thing over 3. Does that make sense? I know the answer looks funny. I get it. You're like, I don't like the way it looks, and I get you don't like the way it looks. But let's stay focused. They want us to isolate the y, and did we isolate the y? Yes, we isolated it by using legitimate steps. Cool? Okay, look at number 3. Number 3 gives me this equation, and they say solve for t. Do you notice it has parentheses in it? So, do you remember what I've mentioned about parentheses? Yeah, they hide the real problem. So do I want to keep the parentheses or do I want to get rid of them? Excellent. Let's get rid of them. And I'm going to get rid of them by distributing that variable p. Agreed? Okay, so this is going to look like a equaling p times 1 is just p plus prt. Do you agree? Okay, stay focused. I need to get that variable t by itself. So everything that's not a t has got to go to the other side. So this term does not have a t in it. So it's got to move over. Just like in problem number 2, this 2x didn't have a y, so it had to move over. Are you with me? Okay, so how do I get rid of that variable p? Yes, I subtract it from both sides. So I end up with a minus p equaling prt. Yes? And then finally, good, I still need t by itself, so you got to get rid of this pr, don't you? By, excellent, dividing since it's attached by multiplication. So over here on the left I have a minus p, and the whole thing is being divided by pr, and it equals that variable t. Did I get the variable t by itself? I sure did. So as funny as that looks, that's my final answer. Good? Okay, let's look at problem number 4. Notice we have a fraction. Remember what I mentioned, not only do parentheses hide the real problem, but so do fractions, right? So I need to get rid of that 5, don't I? Do you remember how we've gotten rid of it in the past? Good. Everything's going to get multiplied by that 5. Remember, there's 2 ways you can do this. All right? So the way I showed you guys was you're going to have to make every denominator with a 5 in it. Correct? Which means top and bottom by 5 on the f and the same on the 32, which will give you 5f over 5 equaling 9 over 5c plus 160 over 5. And now, do I want to keep those 5's? No. Let's multiply the entire equation by 5. And now it's extremely obvious that I'm left with this equation. Does that make sense? Because all those 5's are going to cancel, aren't they? Okay. I need myself a little bit of board space, but let me ask you something. This line right here, I'm solving for c, aren't I? Do you have any idea what you're going to do now? Yeah, you're going to have to get rid of that 160 because it doesn't have a c, does it? Okay, so let me get ourselves some board space. And how are you going to get rid of the 160? Good, I heard you. You're going to have to subtract it, aren't you? Because it's attached by addition, correct? Okay, so when I subtract it to both sides, which means on the left side, we are going to end up with, yes, we are going to end up with 5f minus the 160 equals 9c. Agreed? And c is not quite by itself yet, is it? What are you going to have to do? Good, divide both sides by the 9, which means we're going to end up with 5f minus 160 all over 9 equaling that variable c. Cool? Stay focused on your algebraic steps. You know how to get variables by themselves. Just because there's other variables in the problem, just because the answer looks funny, doesn't mean that how you isolate variables is going to change. Remember your algebraic steps. Cool? Hang in there. I'll be right back with some more problems. Okay, so let's scoot on. Up top here, they gave me two formulas. One is the formula for the volume of a cylinder, and it's V equals pi r squared times h. The other one is for the volume of a sphere, and it's V equals 4/3 times pi times r cubed. Now, here's the deal. Understand what each of these means. In the formula, r stands for radius on both of these formulas. This one has an h. What do you think h is going to stand for? Good, height. So, and pi is just pi, right? All right, so let's look at this first problem. It says that we have a cylinder, and the exact volume of the cylinder is 980 pi. Now you're like, what does that mean with the exact volume? That means they didn't use a calculator. They didn't take 980 and multiply it by pi. They left it alone. So the exact volume of this cylinder is 980 pi cubic meters. And they want you to find the height of this. So which formula are you going to use? Good, since we're talking about a cylinder, we're going to use the cylinder formula, which means the very first thing I'm going to write down is the formula for the cylinder. With me? Now, the one piece of information they gave me was the exact volume. What's the exact volume? Good, 980 pi. So that's taking the place of V. And they're asking me to find the height. Well, if they want to know the height, that means we must know the radius. And according to this diagram, the radius is 7 meters. So we have pi times the 7 squared times h. Does that make sense? Good. It's a matter of understanding the formula, understanding what they've given you, and then plug it in. So we have our algebra to work on, and 7 squared is 49, right? Times pi times h. And we're solving for the what? Good, we're solving for the height, which means divide both sides by 49 pi. Excellent. So I have 980 pi divided by 49 pi equals h. Okay, it's a fraction. What can we do? Good, we can reduce. And when I reduce, the pi's cancel. Even the 49 and the 980 will reduce, won't it? What'd you guys get? I know some of you are on your calculator. Good. We have the height is equal to 20. 20 what? What's my units? Yes, 20 meters. and M is short for meters. Good? Excellent. Okay, let's look at the second problem. On the second problem, they want us to find the exact volume of this sphere. Now, when they say exact volume, stay off the calculator. Are you with me? Okay, so the formula first. If they want to know the volume, that means I better know that radius. Agreed? Do I know the radius? Well, they gave me the diameter, didn't they? Well, the radius is how much of the diameter? Good, it's half, which means if the diameter is 12 millimeters, that means the radius is 6 millimeters. Excellent. Good job, you guys. So my volume is 4/3 times pi times 6 to the power of 3, right? Okay, so I don't have a calculator handy. I know some of you guys have your calculator handy. So me personally, I am just going to work it out longhand since I don't have my calculator. I'm going to reduce that 3 and that 6. So I have the volume is equal to 4 times 2, right? Which is 8 times 6 times 6, right? Okay, so let's see. 4 times 2 is 8. 8 times 6 is 48. And 48 times another 6. Let's see. 48, 4. I got 288 pi. They said an exact answer, which means do not multiply that pi in there. Leave it alone. Because pi is not an exact number, is it? We call it 3.14, but remember, it's a decimal that goes on forever and a day. So if you multiply by pi, now you're rounding, and rounding is not an exact answer. With me? Okay. Now, what's my units? Good. Millimeters cubed. Because I'm talking volume, and volume is a three-dimensional world. Got it? Okay, stay tuned. Got some more problems for us. Okay, let's look at problem number 3. Problem number 3 is asking how much money is in an account after 5 years if $4,000 is deposited at an annual rate of 6% compounded monthly. So they're anticipating you remember the formula that goes with this. Well, the compound interest formula that they're talking about, and because it said compounded monthly, the formula that goes with this looks like A equals P, and in parentheses, times the parentheses, 1 plus R over N times N to the power of T. With me? Okay. So, brief refresher. A is the ending balance in the account. P is your initial deposit, your principal. R is the interest rate. T is time. T always stands for time. And by the way, in the finance world, time is always in years. Years. So if they tell you 6 months, you can't use 6 months. You're going to have to use half a year, or 0.5 years. Got it? And last but not least, N is the number of times per year the account is being compounded. So let's take a look. They said how much money is in an account after 5 years. So what did they tell you already? Good, they told you the time. And the time gratefully is in years, and that is 5. If $4,000 is deposited, so what's the 4,000 represent? Good, the P, the principal, right? And that's in money, I should say that's in dollars. Want to make sure it's not in Russian rubles or something. At an annual rate of 6%. Good, that's your R, and it's a percentage, and you write 6% as that decimal, correct? And then compounded monthly. Well, compounded monthly is how many times a year? Good, 12, which means N is equal to 12. Cool? All right, and now I get to plug it into the formula. So I'm trying to find the ending balance in the account. So A is what I'm looking for. So 4,000 is the initial deposit. 1 plus, good, 0.06 over 12 raised to the power of 12 times 5. Okay. Yeah, you're going to need your calculators on this one, right? Okay. So me personally, I go according to the order of operations. I'm going to work inside the parentheses. So I'm going to take 0.06 and divide that by 12, and then I'm going to add the 1. Gratefully, I have an exact answer here. That's really nice. Otherwise, I would say wouldn't be able to write this as I want to. So inside the parentheses, I got 1.005, and 12 times 5 is 60, isn't it? Okay, next on the order of operations, you take that decimal in your calculator, and you have to raise it to the power of 60, don't you? Okay, that's a decimal that goes on forever and a day. And then finally, yep, you got to multiply it by the 4,000. Now, here's the deal. They're asking how much money, right? So do I really need to tell you how many decimal places to round your answer? Good. I better not, because it's money, and our money only goes to how many decimal places? Yeah, it only goes to 2 decimal places. So hopefully we ended up with the same amount. I got $5,395.40. Hey, I want my 40 cents. Cool? So now you can decide if it's worth it to leave $4,000 in an account for 5 years with this information in order to gain an additional almost $1,400. Hey, it's a real life example, just saying. Good with that one? Okay, let's look at this one. This one's also a real life example. A package of floor tiles contains 24 1-foot, that's square, tiles. How many packages are needed to be purchased to cover this ballroom floor? And the ballroom floor is measured 64 feet by 36 feet. So now here's the deal. You may not be covering a ballroom floor, but you know what? Maybe if you have a house or when you get your own house, you want to retile the downstairs living room or something, and your downstairs living room is in the shape of a square like this one. You're going to need to know the what of your downstairs living room in order to determine how many packages of tiles you need. And some of you are like, I have no idea. Well, here's the hint. They said square, 1-foot square, right? So feet squared. That's talking about, that's right, area. I need to know the area of this flooring because according to the information they gave me, one package, a single package of tiles is 24 1-foot square tiles. I have 24 square feet in one package. Got it? Okay, so first things first. First, we need the area of the floor. And gratefully, the floor is in the shape of a rectangle. So how do you find the area of a rectangle? Good. Length times width, which means you're going to have to do 36 times 64. And what does that give you? No? Okay. Get to your calculators. Yeah, 36 times 64. I got 2,304 square feet. That's how much area I need to cover for this ballroom floor. Okay, now the question is, how many packages of tiles do I need? Well, how am I going to figure out the number of packages of tiles? Yeah, second, so let's see, number of packages. You're going to have to take the area, and in this case, divide by, good, 24, because each package has 24 square feet in it. So we have to take 2,304 and divide by 24. This is feet squared, this is feet squared. They're both feet squared. Okay, let's see what we get. Wow, This went in exactly. What'd you get? Did you get 96? Awesome. So what this tells me is I need 96 packages in order to cover this ballroom floor. Now I'm going to throw a what if at you. What if when we did this division, we got, I don't know, maybe we got 105.7 packages. Do you think they're going to sell you 0.7 of a package? Yeah, no. You're going to have to buy, you would have to buy 106 packages if you came up with a decimal answer. Because they don't sell part of a package, they sell entire packages. Got it? Okay. We were fortunate it came out even, but it doesn't always come out even. I'm just saying. So be careful about that. Cool? Okay. You guys have fun with these formulas, and I'll catch you on the flip side.